What is thermal efficiency in the Rankine cycle? Imagine a power plant that turns heat into electricity. How much of that heat actually becomes useful work? That's what thermal efficiency in the Rankine cycle measures. It shows how well the cycle converts heat energy into mechanical power. In the Rankine cycle, water is heated in a boiler to produce steam. This steam then drives a turbine, creating electricity. Afterward, the steam cools down in a condenser and turns back into water. The main parts of this cycle are the boiler, turbine, condenser, and pump. The boiler adds heat to the water, the turbine converts that heat into work, the condenser cools the steam, and the pump moves water back to the boiler. The net work output is the total work the turbine produces minus the small amount of work the pump uses. Since the pump's energy use is usually less than the turbine's energy gain, the net work is positive. The heat input is the energy added to the water in the boiler, which depends on how much the water's enthalpy, or heat content, increases during heating. To find the thermal efficiency, we take the net work and divide it by the heat added in the boiler. This gives us a ratio that tells us what part of the heat energy is turned into useful work. If the efficiency is 50%, it means half of the heat energy is converted into power, and the rest is lost as waste heat in the condenser. In real power plants, thermal efficiencies usually range from about 30% to 40%. This depends on factors like steam pressure and temperature. Higher pressure and temperature can boost efficiency, but there are limits because of material strength and the high heat needed to vaporize water. Some advanced plants operate at very high pressures and temperatures, reaching efficiencies around 42%. The efficiency of the Rankine cycle is always less than the ideal Carnot cycle working between the same temperature limits. This is because heat is added over a range of temperatures at constant pressure, not at a single high temperature. Engineers improve efficiency by techniques like reheating the steam, preheating the feed water, and lowering the condenser pressure. These methods help increase the average temperature at which heat is added or decrease the temperature at which heat is rejected, making the cycle more efficient. So, thermal efficiency in the Rankine cycle is a way to measure how effectively heat is turned into useful work. It guides engineers in designing better power plants that produce more electricity while wasting less heat.